Hello, how are you doing today? We'll now look at a solved problem under the photoelectric effect. This question says we have to find out how many photons are coming out every second from a laser beam source. The power of that source is given as 10 milliwatts, and the wavelength of the beam coming out from that laser gun is given as 632.8 nanometers. The first thing we do when solving a problem in photoelectric effect is to think in terms of energy. So put down energy of the incoming light beam. E is equal to h into F, where h is Planck's constant and F is the frequency. In the problem, they have given the wavelength, so to find frequency, we will use the speed of light. C is equal to F lambda always. Therefore, frequency F is equal to C divided by lambda, and we will take that further into an equation. The h is Planck's constant. We can either use the number in electron volts or we can use it in terms of joules. Now, because in the problem the power of that laser gun is given in watts, which becomes easier to convert as joules per second, therefore here we will take the Planck's constant in terms of joules. So plug in the numbers and you will get the energy of the incoming photons. Now let's look at the power given in the problem. 10 milliwatts is nothing but 10 joules per second. This power is energy per unit time. So 10 milliwatts would be 10 divided by 1000, that's 10 into 10 to the power minus 3 joules per second. Overall, the number of photons per second coming out of that gun is equal to the total energy per second coming out divided by the energy of each photon. The energy of each photon we found out in the previous slide. So we plug that into this equation and we will get n is equal to 3.18 into 10 to the power 16 photons per second. So that's how we solve this particular problem. Thanks for your time in going through this video. Please do log in into my website www.physicsmodels.in. Have a great day.